Today I'm going to briefly talk about testing and debugging. This is the important part of software development life cycle, where you are expected to test and debug the program you wrote. And it is important for when you are doing software development. In any case, whether you are building SQL or where you are building the C++ code, Python code, Java code, testing and debugging is an important part of the process. Um, and I'm borrowing this slide from the MIT lecture 6001. And One of the things that is shown here is that programming challenges. There is expectation and there is reality, and this the picture on the left hand side is about a girl who miraculously rides a bicycle and parks in the wall. And on the right hand side, there's a boy who tries to um, build a domino and try to uh, create domino effect by pushing one domino, and all the wall falls to the same sequentially after he pushes a domino. So he's trying to build, but he doesn't actually do that, so it is just showing the difference between expectation and reality. And here now we have is when we are writing a program, we always aim for the high quality, but it doesn't really happen. So what happens is that sometimes when you write the code, um, taking the analogy from Professor Srini Devdas, it's like building program is like building a soup, So when you're building a soup, and bug is falling from the ceiling, what would you do? And he says that like either you can check for bugs, or that you can keep the lid closed, or you can clean the kitchen. And checking the soup for bugs is just like akin to testing for a bugs in the lid. And keeping lids closed is akin to defense programming, and cleaning the kitchen is akin to eliminating source of bugs like debugging. So uh, debugging. So defensive programming is basically writing specification for a function, modularizing the programs, and checking contents for inputs and outputs. It's having assertions at the in every module. For every function, every module having some assertions, and modularize a program, like a breaking program into not building a monolithic program, but like breaking the program into small modules. Um, uh, and breaking down into function wise, module wise, like having its own purpose and specificity, and a one like a one, not put everything into one bucket. That's what the modularizing means. And it can be further. The defensive programming can be divided into two parts. One is the testing and validation, and one is debugging. Testing and validation is like comparing input and output to a specification. We have a specification which is kind of requirement for each function, and you compare like input and output, and is it working or no? Like how does it work to compare specification? And also how can I break the program? It's like trying to attack the program to make it break, such that we are making it stronger, and trying to find the bugs. And then it's a debugging. It is like a it is trying to understand like what caused the bug, why it is not working, and how can I fix my program. So these are two branches of defensive programming. And then now then we'll move on to other slide in few minutes.